All right, good morning, guys. We're going to get started. Thank you for joining on time. Tuesday already, so tomorrow we see each other. So just before we get started on the notes and such today, there are a couple of housekeeping items that I'd like to go over briefly. So I'll start off here by sharing my screen so you can see what I'm talking about. Whoops, cancel is not what I wanted to do. Share. All right, so it was brought to my attention that it's a little bit difficult to find something if you need to go back, like a solution thing or a handout or even the YouTube link. Okay, so if you go into your About screen here, what I have done is I have created, so this should be on your About screen. So saved there. So you have the link to my YouTube channel. So if you click on that, that'll go directly to all the videos that are saved. If you click on class notes, it's the shared drive. So I've uploaded all the different class notes, the PDFs, so you don't have to go searching for them if you're missing something. So even the ones from today are there. Handouts. So all the handouts are there, including the shapes and extra handouts I sent you. Then the last two things are handout solutions. So all the solutions to the different handouts. And finally, assignment solutions. So that's the docs and the forms. So everything is uploaded there. So you can just like, I want to look at the solutions to class 5. So I even did the form problems completely out so you can see all of my solutions. And it's just there organized better. So that way you don't have to go searching through this never-ending stream of things in the stream part of it. So I am going to continue posting the notes and all of that stuff in the stream. That way you see it as it comes out. And then later on that day, I'll upload it into the About. The About isn't as pressing because as long as you have it, and it's more for going back to older things. So still check the stream. That's going to be your first line of information. And then if you're going back to find other things, I am going to be posting all of those things into the folders that are in the About section as well. So you have access to that in a simpler way where you don't have to go searching for it all the time if you want to go back and look at some things. Okay, this brings me to my second housekeeping item. I gave you feedback yesterday for assignment number 5. Thank you to the people who completed it. Unfortunately, those people were few and far between. The vast majority of you did not complete it. I cannot stress how important it is to be going over as many problems as possible, because just watching me do a problem and understanding it is not enough, because you on the final exam have to be able to produce that yourself. So if you're not practicing it, you're not going to be able to whip it out of nowhere in the exam. You have to have practice factoring, practice doing the rational expressions, practice doing the next things that we are going to be doing. Because if you're not practicing, you're not going to be able to magically start a problem by yourself. The assignments are a good way too to get feedback. Even though you have the solutions, I post each time and say where you've made your mistake so that you can go back and fix it. To just make you aware of something you're not seeing, or a mistake you're making, or a presumption that you have about a way to handle something and it's not correct. So even though you get the solution to those assignments, it's important to go over them as much as possible so I can give you feedback on what you're doing wrong. So a lot of you are completing the Google Forms. More than half of you are doing the forms part of it, but the assignment part with the long problems is really important too. Any questions on that? Hopefully there are no questions, because you need to be completing both of these things as much as possible. More and more and more and more practice. Last housekeeping item is tomorrow's class. So tomorrow's class, you are in class 10:30 sharp. Sharp, sharp, sharp. This is, in theory, our last class time together because the following Wednesday, you have your situational problem exam, which means attendance is super mandatory. Like no excuse is super mandatory. So this is the last time that we're actually going to see each other face to face and be able to work out any issues you're having. So I really want you to bring questions tomorrow on all the material that we've covered. We'll spend some time just going over that material just to make sure it's really set in stone, because you do have your situational problem on Wednesday of the following week and then your final on Tuesday of the following week. So it's important that we're dealing with these issues as they come up as soon as possible. And like I said, this is our last opportunity to do that face-to-face. Obviously, we can do that between now and then on the computer and all that stuff, what we've been doing lately, but some people may prefer to just get those questions answered on the actual tutorial date when I actually see you. So just keep that in mind for tomorrow. Okay, so please, please, please come tomorrow. Okay, the question is, does anyone know what bus stops at Lindsay Place and the street name? So I'm going to give you a little trick of the trade. Go on Google Maps, type in your house number, type in Lindsay Place High School, and normally it gives you driving directions, but if you click on public transit, it will give you bus directions. So it'll give you the most efficient way to get here by public transit, and it'll give you all the bus numbers where you have to get on and off and all that kind of stuff. So Google Maps, public transit. So you just click on the little thing that looks like a train, bus, or whatever, and it'll give you your best route. It'll give you a couple of different routes. You can even put your leaving time or your arrival time so that it gives you the best route for when you want to get here. Just a little helpful hint there. Any other questions? So we're going to start off by going over the problem that we finished with yesterday, and then from there I'll take any questions about the stuff that we covered yesterday before we move on. Okay? The Google Forms quiz from yesterday. Well, that's because I told you we hadn't covered that yet. Number 3 on the Google form. Okay, and handout 6, number 14. Okay. Assignment 6, number 14, this one. So here you need pen. I need a pen. Here you need a line that is perpendicular to this line. So if we remember, perpendicular means negative reciprocal slopes. So in this case, we need the slope of this, which is negative b over a. So I have negative 10 over negative 8, which is 5 over 4. So if something is perpendicular, I take this slope and it flips and it changes sign. So this one's positive, this is negative. So a line that is perpendicular will have this as its slope. There's only one option for that, and it's B. So this is 100% a question that you could expect to have on the final. This, like as a part A question. Okay? So we're going to try to answer as many of these questions as possible. So one of the questions just before I backtrack to the other ones is, can I go over the changing forms again? So we'll do this quickly. So if I'm changing this to general, so I'm going to change this to general and I'm going to change it to symmetric. So if I'm changing this to general, I'm multiplying it. I need to get rid of this. So I'm multiplying by 2. So 2 times y gives me 2y. 2 times -5 divided by 2, that cancels out to give me -5. And 2 times 6 gives me 12. I need to put this to one side. I need one side to be 0. This is negative, so I'm going to move this over. 5x plus 2y minus 12 is 0. I multiplied by 2. But when you multiply this term, this one, by this one, okay, why did I multiply by 2? Because general form, they're two very good questions. I'll answer one at a time. General form means I can't have a denominator. So I need to multiply by the number that will cancel out the denominator. So you just multiply by whatever the denominator is. And then you have to multiply each term in your expression. A and B could absolutely be different signs. My next example, I'll choose that A and B are different signs. That's fine. Can I do this? Yes, but I can't have a negative A term, which means then I'm going to have to multiply this whole equation by -1 to change all the signs. So 0 times -1 is 0. -5 times -1 is 5. -2 times -1 is 2. And -1 times 12 is -12. So in the end, you get to the same thing, but this is an added step that you avoid doing if you're strategic about which way you're moving these things around. Moving this down, if I am converting this to symmetric, I need the y-intercept and I need the x-intercept. So I'm going to solve for the x-intercept. I'll move this over. So I bring this 2 up, gives me 5x equals 12. So x is 12 over 5, meaning that my symmetric form is x over 12 over 5 plus y over 6 equals 1. If I give it to you in general, you need to calculate three things. One, slope is -a over b, which is -10 over -5, which is 2. The y-intercept happens when x is 0. So this term goes away. So I have -5y plus 20 equals 0. Moving the 20 over, dividing by -5 gives me y is 4. This one I'm converting forms, but if I'm converting forms, I'm just going to calculate a whole bunch of stuff. You'll see why it's a little easier now. Then I need the x-intercept, so that happens when this goes to 0, which leaves me with 10x plus 20 equals 0. So if I bring the 20 over, 10x is -20. If I divide by 10, x is -2. Because I have all this information, I can just quickly make the forms. So y equals ax plus b, and x over a plus y over b is 1. So I have the slope is 2 and the y-intercept is 4. Here I have the x-intercept is -2 and the y-intercept is 4. So just by solving for these three things in general form, you can convert really easily to either one of the other forms. Just very quickly, converting from symmetric to convert to functional, you need the slope, which is -b over a, which is -15 over 5, -3. So I have the slope, and I have that the y-intercept is 15. So this is done. To convert to general, we have the three criteria. First, I have to get rid of the denominators. So in this case, I'm going to multiply the whole equation by, not 5, because 5 won't take care of this. I'm going to multiply it by 15. So here, 15, remember we have the little 1 that we don't see. 15 times 1 divided by 5 is 3. 15 divided by 15 just leaves me with the 1. And 15 times 1 is 15. One side has to be 0, so I'm going to move this over. 3x plus y minus 15 equals 0. So that's how you convert from one form to another for all the different forms. Okay, so I was asked to do the Google form number 3. And the assignment number 2. Class 6 quiz. This is class 6 quiz. So is it even time? Okay, both of these are going to be answered by doing the example we left off with yesterday. So I'm going to do that example, and then I'll talk about how that example relates to each of those two questions. Okay, so the example that we left off with yesterday was this one. So I gave you step-by-step instructions about how to complete this. So we're going to complete it together very quickly. Not very, but quickly enough. So you need to find the area. So I left you with step 1. Step 1 said, calculate the rule of AD in general form. So step 1. Oh goodness, this is really lagging. There we go. So we need this in ax plus b first. So I calculate the slope. This gives me y2. I'm going to reopen this. Give me a second, guys. This is really lagging. It's really lagging for me. Alrighty. So you are calculating the equation. So y equals ax plus b. So you're going to calculate the slope, y2 minus y1 over x2 minus x1. You have 30 and 10 and 90 and 10. This gives me 20 over 80, which is 1 over 4. So y is 1 over 4x plus b. I'm going to plug in either point. It really doesn't matter. 10 equals 1 over 4 times 10 plus b. So 10 is 10 over 4 plus b. And if I move this over, I get 15 over 2 is my b. So I have y equals 1 4x plus 15 over 2. $30 minus 10 is 20. 90 minus 10 is 80. So then 20 over 80 reduces to 1 over 4. I need this in general form. 15 over 2, if you do 10 minus 10 over 4, you get 15 over 2. Type it into your calculator. Using the fraction button, 10 minus 10 over 4 gives you 15 over 2. Or if you prefer, but I really don't prefer it, and I'll show you why in a second, 10 over 4 is 2.5. So if you subtract, you get 7.5, which is 15 over 2. But I'll show you why in a second. That's not ideal. We have to change this to general form, which means we need to get rid of denominators, and we cannot have decimals. We need whole numbers only. So it's a little bit harder to see if we have decimals what we're going to multiply by. So in this case, I'm actually going to multiply by 4. So 4 times y is 4y. 4 times 1 divided by 4 just leaves me with x. And 4 times 15 is the 60 divided by 2 is 30. And then I move this over. 0 equals x minus 4y plus 30. You need this in general form because step 2 was find the distance of between A, D, and B using our new formula. So our distance is going to be AX plus BY plus C with our absolute value brackets over the square root of A squared plus B squared. So what I am doing now is I'm just going to be plugging in my values. So B has coordinates of 40, 60. So we're looking at 40, 60. So this is my A. This is my B. This is my C. This is my X. And this is my Y. So all of those values are plugging it in. If you type in 15 over 2 on my calculator, you get 7R1/2, or whatever that is. Click second function and your fraction button again. And then you should get 15 over 2. What do you mean, which coordinates? 40, 60 are the coordinates of B. We're finding now what we did this for is because we want the height of the parallelogram. The height of the parallelogram is the 90-degree distance between this corner and this line. So we want to use distance point to line. So this point to this line, and we're going to find this distance. So we needed the rule of this in general form, which is what we had, and we use these as coordinates. So now I plug in all my values. A is 1, X is 40, B is -4, Y is 60, C is 30, divided by 1 squared plus 4 negative, all squared. the numbers attached to the x and y are a and b. So this 1 is a, this -4 is b, and this is c. Okay, so if you go back to general form, you have ax plus by plus c. So it's whatever the number is that's attached here to the x and to the y and to the c. So from here, I get, this is 40. Don't forget your bracket. -4 times 60 is 240. And we have 30. It's divided by 1 squared plus 4 squared gives me 17. 40 minus 240 plus 30 gives me -170. The root of 17 is 4.123. Because we have negative, we drop it because of those brackets, so it just becomes 170. And I divide. So I get 41.23. So that, this measure here is 41.23, meaning that is the height of the parallelogram. Now the other thing we need to find the area of the parallelogram is the base. So we need this distance from A to D. So that's just our normal distance formula because it's 2 points. So we plug in what we have. We have 90 minus 10 squared, and we have 30 minus 10 squared. So I get 80 squared plus 20 squared. So that gives me the root of 6,800. And if I square root it, I get 82.46. Meaning that this measure here is 82.46. I want the area of the parallelogram. This is actually just base times height. So I have my base as 82.46, and I have my height as what I calculated here, 41.23. And that gives me 3399.91 units squared. So this actually brings me, like I said, to answering the 2 questions that were asked. Can I change the screen? Are we all done copying? Okay. So this actually brings me to the 2 questions. So just to refresh my memory here, assignment number 2 and number 3 on the forms. Okay. I'll just go here. The docs and the forms. All right. So you could do this problem already, this problem. So it says that the city wants to build an alleyway perpendicular to the main street. Now, as soon as you see perpendicular, there are two different tools that you have. Before you only had one. It was the slope, but now perpendicular, when we're doing distance point to line, we are finding the perpendicular distance between the point and the line. So when they say perpendicular, we're thinking those two different tools, okay? So if I look at this, they want to know this distance, right? They want the distance of the alleyway, and then we need the cost. So this is actually the same couple of first steps as I did in the last problem. So to use the distance point to line formula, I need the distance, I need the equation of the line. So I need the equation of Main Street. I have 2 points, so I calculated exactly the same. Find the slope, find the B, convert to general. Use the distance point to line formula with this point and this line. And then find the cost. Once you have the distance, then you can find the cost because you just do 175 times the distance. So I'm not actually going to do this problem with you. We can do it tomorrow morning because I want to see if you can do this problem. So we just did one identical to that. Apply the exact same method. Is that okay? Is that one a bit more clear for whoever asked me that? Okay. So just quickly, someone else said to clarify. You're welcome for putting everything in folders. I understand the frustration of it not being organized. Okay, so for this problem, we found the rule of the line. So here you have the slope, then we found the B, and then we converted to general. Using the general and this distance point to line, we've used that formula to find the distance. So for this problem, this whole half here, everything on the left side is exactly what you are going to do for this problem. So like I said, I really want to leave you to try it. I will definitely start with this problem tomorrow. That way, if you're still having difficulties, I'll go over it. But I really want you to try this on your own because like I said, it's one thing to watch and see me do it. It's another to try it yourself. So like I said, follow these steps exactly, just change the numbers, and this problem will be the same. Is that okay for everybody? We'll definitely go over this first tomorrow. Wyatt, you were the one that asked me that. Okay. This was the other question that was asked. This is the exact same question. An altitude is a perpendicular distance. It's a line that is perpendicular to the base. So essentially, I'm just going to do this so I can draw on it. So what they are asking is they are asking you to draw. What's the right answer for this question? Guys, just solve it. That's the whole point. You're supposed to practice solving it, not just getting it right. So they want the altitude here. So you're given the coordinates of A, 351173. 351173. So it's the exact same steps. Find the equation of this line. Convert to general. Using this point and this line, find the distance using this formula. There's no y there. There's no x there. Cool. So like I said, I really, really, really want you to try these two problems on your own. And if you're still having difficulty, we can go over them tomorrow. All right. So before we move on to the notes from today, we need to finish the notes from yesterday. Okay. What I'm going to do is we're running out of time. We're like short on time today. So I'm going to post this and the next one with the blue filled out. So take the time to copy down the problems that we're doing together. But in terms of this blue stuff that you're missing, I'm going to post that completed today. Okay, so don't worry about the blue part. You'll have access to that after class today. I'll upload it right away. But other than that, don't worry about the blue stuff. Just worry about the examples. It's just to try to save us time for today. Sorry, choking on my coffee. All right. So in secondary 3, you talk about inequalities in one variable. So you'd have something like 3x plus 5 is greater than or equal to 2x minus 7. And you have to solve for the inequality. But in Sec 4, it gets harder, as per normal. So you're going to be graphing, you're going to be working with inequalities in two variables. Something like this. I'll make it simple. X plus y is greater than or equal to 10. So if I'm picking x's and y's, I could pick x is 2, y is 15, because that's greater than or equal to 10. Or I could pick x is 1,000 and y is negative 500, because that's still greater than or equal to 10. Now my question is, how do I find which solutions I use? So you're looking for pairs of numbers. So for instance, the ones we just used, 2 and 15, 1,000, and negative 500 are legitimate solutions for my inequality. How do we find all the solutions though? So we are looking for all the solutions to that inequality. Basically what this is if I have x plus y equals 10, just pretend the inequality isn't there for a second. That's a line. So I could go here and I could graph my line, x plus y equals 10, and I have a line. What this line does is it separates the Cartesian plane into a top half and a bottom half. So it's half and half. The idea with inequalities is that this line separates it into solutions and non-solutions. So every point in half of this plane is going to be a solution, and the other half is not going to be a solution. So it's our job to determine what this looks like. So if we graph the inequality, arms leaning on that, all right. If I put this in as an inequality, all of a sudden, there's half of the picture that's shaded. What this means is every single point in the shaded half is a solution to my inequality. Any point in the non-shaded half will not give me a solution to my inequality. So what we need to do is we need to determine where and what this looks like. So the inequality itself plays two important roles. It's going to tell us whether we're going to shade the top half or the bottom half. And it's also going to tell us if we can include the points on our line. So if we have greater than or equal to or less than or equal to, our line is the same. So notice here how we had our line, and the only thing that was different was if I take away this inequality or if I put it in, the line itself didn't change. So if I have greater than or equal to or less than or equal to, we include the points on the line. So any point on the line itself also works. And we graph the line as usual, as a solid line. If we have strictly greater than or strictly less than, we cannot include the points on the line. So the points on the line will not give us a true inequality. So what we do is we graph this as a dotted line instead of a solid line. So if I take away this equals, notice how nothing changed, except the line itself went from solid to dotted. So here we have the greater than or equal to, here we have the greater than. Greater than or equal to, greater than. So the shaded region doesn't change. The only thing that changes is the fact that the line went from solid to dotted and vice versa. I can change the direction. If this inequality, then it flips over. You could have less than or equal to, and then at the solid. So depending on what that inequality is, that'll tell me where to shade and whether or not to include my line. In order to, okay, so there's two different things we're going to be doing. We're going to be working forwards and backwards. So either we're going to be graphing the inequalities or we'll get the rules from the inequalities. So we'll do those one at a time. So to find the region, we're going to graph the line. Once we've graphed the line, so however you graph. I'm going to show you a simple way to graph if you want something different. You need 2 points, you sketch the line through. You basically look at the dotted or solid from the inequality sign and you just dot your line. Or don't dot your line. Do solid or dotted depending on the inequality sign. Then you're going to choose a test point. If you can, use 0, 0. Because 0, 0 always, like anytime you have 0 and something cancels out, it makes my life a lot easier. But any point will work. You're going to plug it into the equality to see if it works. If it works, then I'm going to include the half that my test point falls in. And if it doesn't work, I'm going to shade the other half. So let's take a look at what this looks like. So the first thing I'm going to do is I'm going to graph my line. So this is functional form. So I'm going to graph it by starting at +1. And then my slope is 1. So up 1 over 1, up 1 over 1 to find some points for me to sketch through. When I sketch, I notice that this is strictly, so I have dotted line. So that is my line graphed. Now I need to figure out what works. Either I'm shading above it or I'm shading below it. So 0, 0 is not on my line. If it's on my line, I can't use it, but it's not. So test 0, 0. Meaning that if I plug in y is 0, is this going to be greater than or equal to 0 plus 1? So I put a question mark over because I'm testing. Is 0 greater than 1? No, this is false. So 0, 0 does not work. So I shade the other half. 0, 0 is not a part of my shading. And that's graphed. Don't get what part? Do you understand how to graph the line? That's stuff that you definitely have to review, because graphing the line, you need 2 points. So in this case, this is 0 and 1 because we have the y-intercept. Our slope is 1, which is rise over run. So I go up 1 over 1 to get from this point to this point. You just need 2 points, and then you just sketch through. So however you find those 2 points are up to you. So that's one way with the slope and the y-intercept. So putting your first point on the y-intercept and then going up 1 over 1, up 1 over 1, because this is 1 over 1. It is dotted because this isn't there. The underneath line isn't there. If this was there, then we would have made this a solid line. But it's not, so we made it dotted. And then we test. So I'm going to answer this question, both questions on the side. How do you know a point? You can choose whatever you want, anything. I could have tested with this one. What's this one? -13 and 7. Why do I want to deal with big numbers? I don't. I want to deal with simple numbers. 0, 0 is simple, simple. So you could choose whatever you want. So if I tested with 7, -13, I would have is -13 greater than or equal to 7 plus 1? Is -13 greater than or equal to 8? Still no. So I would still end up shading the other half. The only time 0, 0 doesn't work is if it passes through 0, 0. And in that case, use 0, 1 or 1, 0. You can choose anything you want to choose to test. I'm recommending 0, 0 because it's very easy, especially if it's in symmetric form. It's very easy. You don't have to deal with fractions, nothing, nonsense, okay? So just test 0, 0, but choose whatever you want. It really doesn't make a difference for me at the end of the day. How do I graph my line? This is y equals x plus 1. So I have to graph the line y equals x plus 1. So there are different ways to graph. You either do the y-intercept and go with your rise over run for slope. You can graph 2 points. So I could say x is 5. So here I have 0, 1. And then I could say x is 5. So y is 5 plus 1. Y is 6. So I have another point, 5, 6. So I could plot these 2 points. So that's the first one. Do it in red. That's the first one, 5, and 6 is the second one, and I would sketch the line through. So graphing, it's really up to you. At the end of the day, you need 2 points, and you sketch through to make your line. Solid or dotted depends on the side, the value, or how the inequality is presented. Greater than or equal to or less than or equal to means a solid line. Strictly less than or strictly greater than means a dotted line. How do I know which side to shade in? We're going to do 2 more examples of this, so hopefully it's a bit more clear when we do. But with your test point, if you get a bad inequality, so 0 is not greater than 1, and I'm testing, this is my test point. So 0, 0 does not work. So it cannot, 0, 0 is not in the half that's shaded. So since 0 is in this half, I'm going to shade the other half. So let's take a look at a second one. Maybe that'll clear it up a little bit on how to shade. Okay, you need to graph your line. The simplest way to do this is to get your intercepts. So if I'm getting my intercepts, I'm dealing with this line right now. Okay, when I'm graphing, I'm pretending this doesn't exist. So if I have the x-intercept, that's when y is 0. So this part disappears. So 2x equals 12. So x is 6. That's my x-intercept. My y-intercept is when x is 0. So this part disappears. So 3y equals 12. So y is 4. So that is my second point. Now I pay attention to the inequality because all I need is 2 points to graph the line. This is strictly less than, so my line needs to be dotted. Okay, so I'm going to connect these 2 points into a line. So once you have 2 points, you just sketch the line that passes through them. 0, 0 does not fall in my shaded region, so I'm going to test it. Test 0, 0. I'm plugging it into this. So I'm saying, is 2 times 0 plus 3 times 0, is this less than 12? Well, this is 0. This is 0. Is this less than 12? Is 0 less than 12? Yes. So 0, 0 is true. So 0, 0 is in my solution set. So I shade this side. So the shading comes from the test point. If it's true, we shade over the test point. If it's false, we shade away from the test point. Is this a bit more clear to the 2 people who asked me how to shade? Yes, no, maybe so. Instantaneous answer, I like that. Okay, we'll do one more. Just to make sure we're all clear and all on the same page. So I'm ignoring this for now. Easiest way is to find 2 points. I'm going to go with the y-intercept. So the y-intercept, 5y Actually, you know what? Yeah. Which way is better to do this? Okay, I'll do it the other way. So I'm ignoring the inequality. I'm going to change this to functional form. So I'm going to move this over. And then I'm going to divide both sides by 5. So 10 divided by 5 is 2. 25 divided by 5 is 5. So now I can graph the line. So I start at 5. My slope is 2 over 1. So I go up 2 over 1, up 2 over 1, up 2 over 1, just to give me a few points. Not that one. Then I sketch my line through my points. It is dotted because this is just less than. Perfect. Now, 0, 0, not on my line, so I'm going to test 0, 0. I am testing it in the original inequality. So 10 times 0, is this less than question mark? 5 times 0 minus 25. Is 0 less than 0 minus 25? Is 0 less than negative 25? Nope. Shade other side. So this is false, so this side must be the true side. Da-da-da. All good? Okay. This is an inequality. So I'm going to answer the two questions separately. Where does shade? Basically, your inequality could be true or your inequality can be false. Because 25 is not less than 2. It's greater than 2. So either an inequality is false or an inequality is true. If the inequality is false, then that point doesn't solve my inequality. So when I'm testing a point, it's because either all the points on one half of the line are going to solve my inequality to give me a true inequality, or all the points on the other side will solve my inequality to give me a true inequality. So I need to figure out which half it is. So I pick any point in the whole Cartesian plane and I test that point. Does it give me a true inequality or a false inequality? If it gives me true, I shade that half where the point is. If it gives me false, I shade the other half where the point is not. 0, 0 doesn't have to be your test point. Your equations become more complicated if you're not choosing 0, 0. So that's why we're testing. Okay. How would we know when to use something like this? The questions are going to be very clear. We'll get to that in a second, but these are the types of questions you would get. So this is an example just quickly, but like I said, we'll go back to this. This is an example of a part A question. Very clear half planes. This is an example of a question. Very clear half planes. Or it would be graph it. The other case scenario would be like this. In a part C question, they give you, number 50, it gives you the inequality. If you see the word half plane, you're automatically doing something like this. So either it's going to show you an inequality, or it's going to say half plane and give you the inequality. Okay. So the other things we can do with this are as follows. Working backwards, given the picture to create the inequality. So here you have the picture. You're going to make the equation of the line. You're going to test a point to see, you're going to test a point in the shaded area. And then you're going to create your inequality. So let's take a look at what this looks like. Create the equation of the line. Now this is where symmetric form comes in extremely handy, because symmetric form takes the intercept. So this is going up by 2. So this is 2, 4, 5. So if we're working with symmetric form, you don't have to, but if you're working with symmetric form, it makes your life a lot easier. So this is 5. This is 2, 4, 5 as well. It's going to be clear on the graph what those numbers are. So this is the rule of my line. I don't have to do the y equals ax plus b and solve and all that nonsense, because I have symmetric form, and look how easy that is. Now I'm going to take a point in my shaded region. If 0, 0 is in there, fabulous. So you're going to plug in 0, 0, knowing that it should give you a true inequality. So I'm leaving this blank because I want to know how to put this in. How do I know what? Just before I continue. The question is, how do I know that? But I don't know what that is. You have two options. Either you're finding the rule as y equals ax plus b, or you're using this. It doesn't matter what you use. With symmetric form, it's just the x-intercept and the y-intercept. So the x-intercept goes here, the y-intercept goes here. That's it. That's symmetric form. So you take wherever it hits the x-axis and wherever it hits the y-axis and plug those numbers in. So here, 0, 0 should be, it needs to be true. So 0 plus 0, 1. 0, 1. For this to be true, 0 is less than 1. Notice I'm not changing anything's sides. If it's on the left, it stays on the left. If it's on the right, it stays on the right. This is a solid line, meaning that I have greater than, or sorry, less than or equal to. So I just plug this back in. And that represents the shaded side. Let's do another one. Try to use symmetric form. Makes your life a lot easier. Obviously, you can only use this if you have really nice intercepts, but most of the time you will. So in this case, I look for the y-intercept and the x. So the x is -2. The y-intercept is 4. That's the rule of my line. I cannot use 0, 0. So I want to choose something that's in this solution set. Really doesn't matter what it is. I'll choose this point here. So test negative 10, 0. Doesn't matter which point you choose. So I plug this in. Negative 10 over negative 2, 0 over 4, leaving this equals blank because I'm turning it into an inequality. So negative 10 divided by negative 2 gives me 5. This is 0. So plus 0, 1, 5, and 1. Is 5 greater than 1? So 5, I don't know if you remember this. Some people use this. The alligator mouth eats the bigger number. So this is greater than. It's dotted, so it stays like this. Now this just plops in and replaces the equal sign. We're done. One more. Again, use symmetric form if you can. So my y-intercept is 8. My x-intercept is negative 7. Sweet, I can use 0, 0. So I plug in 0 here and 0 here, leaving the space for the inequality. Well, this is 0 and this is 0. So 0, 1. Which direction does this go in? Alligator mouth eats the bigger number. It's dotted, so it stays like this. So I get x over negative 7 plus y over 8 is less than 1. So quickly, just to finish this off, we'll look at 2 problems that are something that you could expect to handle on the final exam, okay? This type of question comes up extremely frequently. So it's a multiple choice, it's a part A question. It gives you the relationship and it says, figure out which graph this belongs to. So what you're doing is you're doing a process of elimination. So the first thing you always check, because sometimes you can eliminate 2 out of the 4 cases just by doing this, is checking to see if it should be dotted or solid. In this case, it's dotted. They're all dotted. That doesn't help me. What is different between these 2 and these 2 are the intercepts. So I'm going to solve for one of the intercepts so I can compare. So x-intercept, for instance, happens when y is 0. So if y is 0, this term disappears. So I get 5x plus 75 equals 0. 5x is negative 75. So dividing by 5 gives me x is negative 15, meaning that the x-intercept of this should be negative 15. So I've just eliminated this case and I've eliminated this case. Because in this case, we have x is 25, so gone. Test 0, 0. Either it's true or it's false. So 5 times 0 minus 3 times 0 plus 75, is this greater than 0? This is 0. This is 0. Is this greater than 0? Is 75 greater than 0? Yes. So I have C. The other question is, this really should be a multiple choice, but you could get it as a part B as well. So what ends up happening is you have to create the inequality. So in this case, you don't have the two intercepts, so you have to use y equals ax plus b. So I find the slope. So that gives me negative 20 minus 20 over 80 minus 0. So that gives me negative 40 over 80, which is negative 1/2. So my rule is negative 1/2 x. This is b, so plus 20. Test 0, 0, because 0, 0 is true. 0 blank. Negative 1/2 0 plus 20. 0 blank. This is goes away. 20. I want it to be in this direction, and I want it to be greater than or equal to. So my rule is y is less than or equal to 1/2 x plus 20. In this equation, in y equals ax plus b, just to answer the question, how come I picked 20 as b? B is the y-intercept. This is where it hits the x-axis. It hits at 20, so that plugs right in.
Okay, so
Okay. So those are the type of exam questions that you can pick. Okay? All right. Let's roll. So I'm just going to save this as group 2 before I forget. Okay. So if there are no more questions on that, we're going to move to today's notes. So we're really running low on time. So I'm going to try to get through as much of this as possible. So in terms of review, I'm going to post these notes once again filled out. So just worry about copying down the examples. Okay. So today the plan was to review properties of functions very quickly, to review quadratic function very quickly, and to start something new. So I'm going to just review property, like I'm going to talk about it super quickly because you did this in CST and you did this in Sec 3. So properties of functions should be taken care of. If someone has never seen this before in their life, please let me know and I'll slow down and try to actually go over this thoroughly. But like I said, these notes will be filled out and uploaded for you. Any takers on never seen this before in my life? This is now on the second set of notes. So today's notes, class 7 notes. So the notes that were posted yesterday. So any takers on I've never seen this before in my life? Really? Okay. All right, domain. Domain is a set of all possible x values the function can take. So we're dealing with graphs. Okay, we have different graphs like this. that we're studying. So we want to know different properties about these graphs. So first and foremost, the domain is the set of all possible x values the function can take. The range is the set of all possible y values the function can take. So if we look at this picture, before we don't have those y values or x values as legitimate points on my graph. So they're not part of my domain or my range. So it's only the y values and the x values that are on the function. Y-intercept, the value where the graph crosses the y-axis. So we did this with lines, it's wherever it crosses the y-axis. And then if for algebra, you're going to set x as 0 and solve for y. The other property is the x-intercept. It's the value where the graph crosses the x-axis. So this can still be a function even if there are multiple x-intercepts. So notice here how we have in this picture, we have one y-intercept, but we have multiple x-intercepts. That's fine. This is still a function. It passes the vertical line test. So then we have the extrema. This is the maximum or minimum y value that this function takes. So if we look here, the top y value that it takes, since this goes to infinity, would be, there's no maximum. The lowest value we see is this one. Then we have the variation where the function is either increasing, decreasing, or constant. So constant means there's no change in the y coordinate. Increasing means as we read, we always remember that we read the graph from left to right. So as we move from left to right, there's an increase in the y values. And if it's decreasing as we move from left to right, the function's going downwards. So there's a decrease in the y values. Constant part is both increasing and decreasing and gets included in both of these intervals. And strictly increasing or decreasing does not include the constant sections. So once again, we were reporting the x coordinates where the increase or decrease is happening, not the value of y. The sign. Sign tells us where the function is above the x-axis and when it is below. So essentially, you are scanning here to see when it is above and when it is below, because this is positive, this is negative. So you're just saying, okay, well, it's below up until here. It's above up until here, then it's below until here, then it's above again. So that's positive, negative, above and below. Inverse is new for everybody, theoretically. So we're going to take a look at this together today. And just to put all of this together, when you're doing a study of a function in its entirety, you need to talk about domain. You need to talk about all of these, but certain one of them involve x values and certain one of them involve y values. So domain, x-intercept, variation, and sign all involve the x values where something is happening. The y values, properties that use the y values are range, y-intercept, and extrema. So you're reporting y values for that. So the range, the highest y, you just give the highest y. For the y-intercept, you give the y-intercept. For the extrema, for the range, it's the possible y values. For the extrema, you give either the max or the min y. Okay? So that's properties of functions. So you could take a minute to try to define the properties of this function, or there's one on the handout for today that you can take a look at as well. This Should absolutely be review for everybody. So we're really going to go through this quickly. So we have the quadratic function. We have y equals x squared. So you did this in CST as one of the functions that you covered, along with the periodic, the piecewise, all of that stuff is all included here. So make sure you're paying attention to that. So quadratic, like I said, you've covered. So we have, this is the more advanced case. This is the transform function, y equals ax squared. So we know that a affects the positioning of the parabola. If we have a positive a, that means that the parabola opens upwards. A negative a means that the parabola opens downwards. This value of a either shrinks or opens up the parabola. So for instance, we have that picture. Let's go to this. Y equals, I'm not typing, y equals x to the 2. And if I put an A there, add a slider, fantastic. Here's what I got. So the bigger A becomes, the skinnier the parabola becomes. If it gets closer to 0, it gets wider and wider and wider. If it becomes negative, it flips over and opens downwards. The closer it is to 0, the wider it is. The further away from 0, the skinnier it is. So A plays those two roles separately. So you have different type of parabolas. So you have the upwards one, which means A is positive. So the bigger number here would be, the biggest number would be the green. So the further away from 0 you get, the narrower your parabola gets. So you have the upwards cases and the downwards cases. Okay? To graph, chances are you're not going to be asked to graph this, but just like on a side note, to graph, just make a table of values. And then you know the general appearance of what a parabola should look like. So once you have your table of values, you can just plot a whole bunch of points and generally sketch your parabola through. We have the transform function. Once again, the y equals ax squared. How do we find the rule? We write down y equals ax squared. We plug in a point, anything other than 0, 0. We solve for a. And then we use that to answer any questions that may come up afterwards. For instance, we're going to do number 3. Given that a second degree function, that's a parabola, passes through the point -6, -12, find the following values. So the first thing we're going to do is we're going to find the rule. Y equals ax squared. But for us, if we remember, all we need is 1 point. So my y is -12. My x is -6. -6 squared is 36. And I divide by 36 to give me -1/3. So my rule is y equals -1/3 x squared. -12, -6. It's from the point that you were given. No, no worries. I'd rather you ask. Perfect. Make sure we're all on the same page. Sometimes I forget to say something, so it could have been that too. So always ask. Hey, this means x is 12. This means y is -27. So here I'm plugging in x as 12. So y, if we have 12 squared, we have 144. This gives us -48. So 12, not 12, yeah, 12, cool. 12 and -48 is a point on my parabola. B, we have y equals negative 27. Why did I write 25? Oh my goodness. Negative 27 equals negative 1 over 3x squared. So the negatives cancel out and we get 27 equals 1 over 3x squared. If I bring this up, multiply, it gives me 81. Okay? I square root to get rid of the 2. But in this case, what is the square root of 81? Well, it's 9 or negative 9. So we actually have two different points. I have 9 and negative 27, and I have negative 9 and negative 27. So just as a reminder, when you're working backwards with quadratic functions, you end up with two different possibilities. It's x squared because this is a quadratic function. So a quadratic function or parabola has x squared. Okay. Cool. So that, like I said, the handout for today, you'll take a look at it. It's majority quadratic. Okay, a couple of different piecewise and periodic stuff thrown in there, but most of it's quadratic. Quadratic, 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 all that stuff. So check it out. It's a lot of review, but it comes up a lot. And understanding that really helps us understand what we're doing next. This is where we get to the new material, okay? So we're going to try to do as much as we can before the end, which is fine. And then whatever we don't finish, we'll pick up tomorrow. The inverse of a function is a new picture. Could be a function, could not be a function, where the x's and y's of the original function are all completely switched. So every ordered pair, every xy pair switches. So we have 2, 7. On the new function, this would be 7 and 2. So for every single pair on the picture, they switch. Meaning that the domain, which is all the x values, becomes the range, the y values. And the range, all the y values, become the x values. So this is just saying this in a real formal sense. Graphically speaking, we are doing a reflection. So an inverse is a reflection over the line y equals x. So that is what an inverse is. Now, if you remember, some of you may have seen this, some of you may not. In elementary school, you had those red things when you were doing reflections. So it was like this see-through piece of plastic where you would put it on your reflection line and then you can copy it and you can do the reflection. So essentially that's what we're doing. We're reflecting a function. Okay, so we're just going to do a couple of graphs, really sure, well, like as sure as I can be, like 95% sure that you're not going to have to do this by hand on the exam, but we're going to do it just in case. So what you are doing is you're reflecting over the line y equals x. So like I said, this is just to give you a visual. So essentially what we're going to do is we're going to take a couple of points and we're going to flip them. So this one is at 0, 5. So my new point is going to be at 5 and 0. It's going to flip. Let's take another point. This is another point. Negative 1, 4. So I'm going to have 4 and negative 1. Here I've got another one, -3, -1. So I'm going to have -1, -3. What about down here? Down here I've got -7 and -9. So on the new function, I'm going to have -9, -7. So like I said, just to give you a visual, did I mess one of these up? I think I did. Maybe not, we'll see. Yeah, I definitely did. That's -3. Yeah, that point should be at this here. +3. This should be at 3, -1. And this point should be 1, 2, 3, -3, and -1. This should be -1, 1, 2, 3. That one's weird. We'll forget about that one. In any case, what we see is a mirror image. So if we look at it a bit bigger, not much bigger, anyways, blue and red are mirror images of each other. Okay, so that's the reflection. So we'll do the same thing here. We're going to take some points and then we'll reflect them. So in this case, I have 0, 0, which stays 0, 0. I get, here I have 2 and 4. So my new point is going to be 4 and 2. Here I have -2 and 4. So I'm going to have 4 and -2. I also have 3 and 9. And I have -3 and 9. So those both go on as well. So I have 9 and 3 and 9 and -3. So I sketch this through as best you can. And you see that this is really a reflection here over this line. Okay, so if you extend this line, you'll see that it's a reflection, okay, over. So it's mirror images of each other. So like I said, graphically speaking, you're probably not going to have to do that on the exam, but you never know. Thank you for answering that question on this chat. This is just a quick check. So we have the vertical line test to see if something right in front of us is a function. We have a horizontal line test to tell us if the inverse of this picture is going to be a function. So if I take a horizontal line, why is it in red? I wanted it in black. If I take a horizontal line, essentially what I am doing is I'm testing to see if I have any points on the same horizontal. Because if I have 2 points on the same horizontal, the inverse will not be a function. So this is super clear. As I scan up, I have tons of points on the same horizontal. Tons. So the inverse of this will not be a function. Inverse, not a function. We test this one. It's a little bit hard to see. But if I scan this, It kind of looks like it is there, but it's actually, if you zoom in, it's not. So I'll just let you know. So we don't really have, oh, sure, just stop working. We don't really have any 2 points on the same horizontal. So the inverse of this is a function. So when you're doing, if you're determining that something is a function, you're doing the vertical line test, right? Remember? So I'm scanning over to see if I have any points on the same vertical. So because this is good to go, this is a function. Same thing here. But to see if the inverse will be a function, I'm seeing if there are 2 points on the same horizontal. So in this case, since I have 2 points on the same horizontal, the inverse is not going to be a function, and vice versa. So here that wasn't good, here it was good. Because when you're finding the inverse, you're rotating it sideways. So if I'm rotating this sideways, theoretically, because I'm flipping it and rotating it. So just for the sake of argument, I'm flipping it and rotating it. Now, this doesn't pass the vertical line test. So it's just a way of analyzing it so that I don't have to flip it. That I can just leave it like this and still analyze it. So same thing here. Doing the horizontal line test is like doing a cheat vertical line test. It's saying here, well, if I flip it, and this isn't exactly going to be the inverse, because to find the inverse, you actually have to flip and rotate. Which is really hard to do on this. But here, this will pass the vertical line test, so we're good to go. So it's just a cheat way of doing the vertical line test to see if the inverse is going to be a function without actually having to find the inverse. Okay. Algebraically speaking, we have to be able to find the inverse. So if you're just given a whole bunch of ordered pairs, you're just switching the x and y values. So we did a quick example of that at the beginning, but you're just switching the x and the y values. If you have a rule, you're switching the x and the y values, and we are isolating y. So we'll take a look at what this looks like. Before I continue, the question on the side is, so if there are 2 points on the same horizontal, the inverse will not be a function. And it's just like the vertical line test, you just take it as that. So there are 2 points on the same horizontal, the inverse will not be a function. Okay. So if I have these and you want to find the inverse, these are just ordered pairs. So I take each of the ordered pairs and flip them. So they all become 7, 5, 7 becomes 7, 5. -4, -8 becomes -8, -4. And 2, 12 becomes 12, 2. So inverse is just I'm flipping these points around. If I have to do this algebraically, you switch the x and the y value. So step 1, switch the x and the y value. And now I'm going to work to isolate the y. So the first thing I'm going to do is move this to the other side. And I'm going to divide by 2. Giving me x over 2 minus 7 over 2 equals y. So these two things are inverses. So if we look at them, you can see that they are reflections of each other. If you kind of turn your head a little bit, you'll see that they're reflections of each other sideways. The question is, could x over 2 also be 1 over 2x? Absolutely. So you could write this if you want as 1 over 2x minus 7 over 2 equals y. Another one. So here to find the inverse, we switch them. So x equals y minus 4 divided by 2. So I'll move this 2 up. And then I'll move this 4 over. So I get 2x plus 4 equals y. So these two things are inverses. We'll do one more. Super important, actually. So find the inverse. You switch the x and the y. So I divide by 2. Now I need to get rid of this 2 here, so I square root both sides completely, which gives me the root of x divided by 2 equals y. So this is the inverse of, why did I go that way? This. Now, as of right now, this type of function with a square root x and y doesn't mean much to us. So we'll just take a quick look here. Y. So these are our inverses. But what do we notice? We notice that the purple, the inverse, is going to fail the vertical line test. It is not a function. So what we are going to do is we are going to only consider half of it. So this is just the top half. And now this is a function. We call this the square root function, which is the inverse of a quadratic. So our issue thing here is that the inverse of a quadratic is not a function. If you just test it, see if we test it here, that's what the beauty of the horizontal line test is. If you test this, you see it's not, the inverse is not going to be a function. But we want to work with that kind of function. So we keep it a function. We call this the square root function. And we can say function now because it is a function, because we took away half, the bottom half, and now it passes the vertical line test. No, I guess that's one way to do the vertical line test. It passes the vertical line test. So what we are going to do tomorrow is we're going to talk about the square root function, what it looks like, what we do algebra with it, There are a couple of questions in the assignment and the handout that have square root functions, so you can just ignore those for now, unless you feel ambitious and feel like you can try it. Other than that, try to do as much of the package, like I said, as possible, because most of it's quadratic, which is a good review, and then we can fix any issues tomorrow during class. Bring as many questions as possible tomorrow. Remember to print out the notes and bring them tomorrow. If not, I'll have some extra copies. The notes will go up in about 45 minutes. I will be posting these notes in about 5 minutes after the class. Just gives me time to organize it and then upload it. Make sure to go and complete the assignment and the Google form from yesterday, because now you can do all those questions with these things, with the inequalities and graphing. So check that out so that way you can get feedback on that. I'll be giving feedback for I will be giving feedback for assignment 6 tomorrow. The pages are numbered. They should be numbered. Okay. Question was, can I number the pages? Yeah, I'll just include that. I thought I had included it, so it's my mistake. If they weren't numbered, they should have been. So I'll number the pages. So bring all your questions, bring all your documents for tomorrow, and get ready for a great class. So I'm looking forward to seeing you all tomorrow, and have a great rest of the afternoon.